Okay, here's problem 2. Problem 2 says we've got this wedge right here with dimensions a length of 7, height of 11, and a base of 3. And we want to figure out what the volume of this wedge is. Okay, so look at this. I've drawn some example slices. What we're going to do is we're going to slice this thing like this along this x-axis here that we've set up. And we're going to measure the area of each slice. Notice that each slice is a triangle. And we're going to add each area up in order to find the volume, because that's how we find the volume of stuff. We slice it up, we add the area, and there we go. We get volume. Okay, so remember that it's important that we have the axis set up this way. See, this is the 0 of the x-axis, is the origin. And here's the positive direction of the x-axis. And whenever you're doing these problems, there's some later problems that won't give you pictures, and so you'll need to figure out how to orient yourself so it's real convenient and easy to integrate these. Well, relatively easy. So, what we need to know is that, look at this, x drives the dimensions of this triangle. And when x is 0, our height, let's see if we can see that better, is 11. And when x is 0, our base is 3. Now look at over here. When x is 7, we have a height and a base of 0. So look at, there's some sort of relationship. Whenever x is in any position down this line, we get a height and a base. So that's important. And I was thinking for a while, how could we relate this? How could we get x to relate to this height? How could we get x to relate to this base? And then it dawned on me, oh yeah, we can create some equations of lines to determine how x drives the height, which is pretty cool, because now look at that right here. Look, see, this is a line right here, and this is a line right here, and x drives, pardon me, this isn't the line that we want to know. This, see, we want to know this height and this height, so we look at this line and that line. Okay, look at that. That's super important. So, again, this line right here, we can lay it out in 2D. We get this. See, when x is 0, the height's 11, and when x is 7, the height is 0. And that's enough information to allow us to find the slope, -11/7, and create the equation of that line. See, just done the work here. And you can pause it and see what I've done there, but that's just from pre-calculus and how we create equations of lines. Similarly, this line right here, we can transcribe it down into the paper here, and we get an x-intercept of, 7 right here, y-intercept is 0. I'll scratch that. X-intercept is 7. And the y-intercept is 3. And using those two points, we can again use all that information to find a slope and use the formula. You can either use the slope-intercept formula or this is point slope, what I've done, but either or works. And you can find the equation of that line. So what we've done all together on one page here is we've figured out, based on wherever x is on this line, see, x could be here and we'll find this height and this base, or x could be down here and we'll find this base and this height. Right here, here it is, here's the equation. For this height right here, the height of the triangle, we have this -11 x plus 11, this is the height there, and the base here is -3/7 x plus 3. That'll give us the base, depending on what x is. And remember that we're starting here and we're integrating out here, so that means our lower limit of integration is 0 and our upper limit of integration is 7. So that's what we found. We found the area based on x. And we know that this is a triangle, this slice is a triangle, so we know that the area of a triangle is 1/2 base times height. So that's 1/2 times the base, which is this guy, and times the height, which is that guy. And so our formula is the integral from a to b of the a of x dx. Well, we go in and plug all the information we just worked on. The a of x is all of this guy, and the dx just comes along for the ride. And then the a to b is our upper and lower limits of integration right here. And then the integral finishes out. I didn't bother to finish it. I suppose I could. You can let me know if I need to, but this is something that would be good practice if you don't remember how to do it. And if you don't remember how to do it, then let me know and we can work on it. Let me know if that was any clearer. It's kind of difficult to explain these over an iPod.